Hello everyone, welcome to Study Channel. Today we are going to start the chapter Ray Optics and Optical Instruments of Grade 12 CBSE. Let us dive into the chapter right now. The chapter consists of these topics basically, but each topic has its thing to say. Let us dive into the introduction now. The introduction, you see the definitions of a few terms that you've already learned in your grade 10th. Now, let us dive into it. Light. What is light? It is an electromagnetic wave with a wavelength of 400 nanometer to 750 nanometer, and it gives us a sense of vision. Okay? So, this you've already, obviously you would have learnt in your grade 10th, right? A ray of light means a path of light. Beam of light is a bundle of rays. And the phenomena that is covered in this chapter basically will be reflection, refraction and dispersion. And obviously we'll see about the image formation by the surfaces. Plane surfaces means the plane mirror and all, and the spherical surfaces, concave, convex mirrors, and the lenses, all those will be encountering in this chapter. And optical instruments, you will see, that is the construction, its working, the human eye, everything you already learned in grade 10th, but quite a few topics included you will be learning in this, right? Now let's see what our NCERT has to say. So, ray optics and optical instruments. Let us start with the introduction. Nature has endowed us with human eye retina with a sensitivity to detect electromagnetic waves. We already have retina in our eyes with a sensitivity to detect the electromagnetic waves within a small range of electromagnetic spectrum only, and electromagnetic radiation belonging to this region of spectrum of a wavelength 400 nanometer to 750 nanometer is called light. It is mainly through light and the sense of vision that we know and interpret the world around us. It's mainly through light we can sense our vision and encounter the objects around us easily. Without light, there is nothing we can do. And there are two things that we can intuitively mention about light from the common experience. First, it travels with enormous speed, it's having enormous speed. And second, that it travels in a straight line. That's what we have been taught in our grade 10th also, right? It travels in a very straight line and it travels with enormous speed, and that's what we've been taught. So its speed, when you have to say it is, a correct value will be 2.99792458 times 10 power 8 meter per second. But for many easy purposes, for taking it, we will be taking with approximate measure, that is C means speed of light equals 3 into 10 to the power 8 meter per second. The speed of light in the vacuum is the highest speed attainable in nature. So where the speed of light is highest, it can be a question too. So you have to learn line by line. Speed of light is highest in vacuum, and that is the highest speed which is attainable in nature. And the intuitive notion that light travels in straight line seems to contradict what we have learned in chapter 8. In chapter 8, if you see, they have been said that light is an electromagnetic wave of wavelength belonging to the visible part of the spectrum. So how can we reconcile the two facts? The answer is that the wavelength of light is very small compared to the size of the ordinary objects that we encounter normally. You see, the wavelength of light, the wavelength is 400 nanometer to 750 nanometer, which is really very small, right? But the objects around us, if you see, it is really large, so that we can encounter with our vision. But the light is not like that. It is having a very small wavelength in such a way that we can't encounter it in normal life. And so it's generally of the order of a few centimeter or a larger than objects that we see around us. But the light is of nanometers range, that is 10 power minus 9 meters. 10 power minus 9 meters. So hence it's obvious that we can't see the light, the wavelength of light. Okay, yes. So next, when you see the path is called a ray of light, and bundle of such ray constitutes a beam of light. In this chapter, we'll consider phenomena like reflection, refraction, dispersion of light, and using the ray picture of light also we will use this. Using the basic laws of reflection and refraction, we shall study the image formation by plane and spherical reflecting and refracting surfaces. We then go on to describe the construction and working on some of the optical instruments also. So this is the basic introduction of the light chapter, and yeah, let's see the next video with the next topic, reflection of light by spherical mirrors. Thank you.